Most people hear a single statement repeated over and over again. Nothing can move faster than the speed of light. It sounds simple. It sounds final. But by itself, it explains absolutely nothing. So instead of memorizing the statement, let's actually understand why this limit exists at all. Start with something completely ordinary. Drop an object. It falls. That simple fact was studied carefully hundreds of years ago. Not just noticed, but measured. People wanted to know exactly how things fall and why they do it the same way every time. Now think about the moon. The moon does not fall straight down to Earth. It stays up there, moving in a smooth path around the planet. At first glance, that seems completely different from a falling object, but it isn't. The moon is falling. At every moment, gravity is pulling it toward Earth. If the moon were not moving sideways, it would crash straight into the planet. But because it is already moving forward, it keeps missing the Earth as it falls. That continuous falling, combined with sideways motion, is what we call an orbit. This idea allowed physicists to connect things that once seemed unrelated. The same force that pulls an apple downward also controls the motion of the moon and the planets. When gravity was described mathematically, something remarkable happened. The equations didn't just explain motion after the fact. They predicted it. The amount an object falls near Earth, the path of the moon, and the shape of planetary orbits all followed the same rule. Different situations, one law. This was a turning point. It showed that nature follows deep, consistent patterns. Later, astronomers began testing these patterns more carefully. They looked far beyond Earth, tracking the motion of Jupiter's moons with extreme precision, and something strange appeared. The moons did not always show up exactly where the calculations said they should be. Sometimes they were early. Sometimes they were late. At first, this looked like a failure of physics, but the orbits themselves were fine. Nothing was wrong with gravity. The problem turned out to be light. Light does not reach us instantly. It takes time to travel. When Jupiter was closer to Earth, the light from its moons reached us sooner. When Jupiter was farther away, that same light took longer to arrive. Once this delay was accounted for, everything made sense again. But this realization changed physics forever. It meant light has a finite speed, and once that speed was measured, something deeply unsettling was discovered. No matter how fast you move, light always travels at the same speed relative to you. If you stand still and measure it, you get one value. If you move toward the light and measure it again, you get the exact same value. This goes against everyday experience. Normally, speeds add together. If you move forward and throw something ahead of you, it goes faster. Light does not behave that way. You can chase it. You can move toward it at extreme speed. It still pulls away from you at exactly the same rate. This strange behavior forced a radical conclusion. If the speed of light never changes, then something else must. Space and time themselves cannot be fixed. They must adjust. This was the insight that led to relativity. Time slows down for moving objects. Distances shrink in the direction of motion. These effects are not illusions. They are not errors in measurement. They are physical changes. They happen so that everyone, no matter how fast they are moving, measures the same speed of light. As an object accelerates closer and closer to that speed, something else happens. It becomes harder to push, not because engines stop working, not because fuel runs out, but because the object's resistance to acceleration increases. The closer you get to the speed of light, the more energy it takes to go even a little faster. To actually reach the speed of light would require infinite energy. And infinite energy is not something the universe allows. That is why objects with mass can never reach light speed. Light can move at that speed because it has no mass. But the limit itself does not belong to light. It belongs to space-time. It is the maximum speed at which cause and effect can propagate through the universe. Even if light did not exist, this limit would still be there. You are always moving through space-time. If you are not moving through space, you are moving fully through time. If you begin moving through space, some of that motion must come from time. The faster you move through space, the slower you move through time. There is a maximum. At the speed of light, there is no motion left for time at all. This is why light does not experience time. From its perspective, emission and absorption happen in the same instant. This is not speculation. Particles in accelerators behave this way. Satellites must correct for time differences to work properly. Fast-moving particles survive longer than they should unless time slows for them. Every experiment confirms the same structure. The speed of light is not an arbitrary rule. It is not a coincidence. It is built into how reality works. It defines how space and time are connected. It defines how information travels. It defines the boundary between what can happen and what cannot. The universe is not obligated to match human intuition.